Assalamualaikum warahmatullahi wabarakatuh. So today our group will present about X bar and S chat for assignment 2 as EMN 3823. So this is our team members. We have 4 team members. First we have Nur Amira Afrina. Second one is me, Muhammad Ainul Yakin. The third one is Muhammad Iqbal Faiz, and the last one is Nur Hidayah binti Ishaq. So this slide will cover about 4 topics, which is introduction, example, application, and benefits. We start with the first one is introduction of X bar S chat. So what is X bar and S chat? Basically X bar, S chat are often used control chart to examine the process mean and standard deviation over the time. These charts are used when the subgroup have large example size, and S chat provide better understanding of the spread of subgroup data than range. So X bar S chat are also similar to X bar R control chart. The basic difference is that X bar S chart plot the subgroup standard deviation, whereas R charts plots the subgroup range. So understanding of X bar S chart. Yet the X bar S chart is very similar to the XR chart. The major difference is that the subgroup standard deviation is plotted when using the XS chart, while the subgroup range is plotted when using the XR chart. One advantage of using the standard deviation instead of the range is that the standard deviation takes into account all the data, not just the maximum and the minimum. And the constants used to calculate the control limits and to estimate the process standard deviation are different for the XS chart than for the XR chart. As for the XR chart, frequent data and a method of rationally subgrouping the data are required to use the X bar S chart. So we will see the basic shape of X bar chart. The figure below are an example of an X chart. A company is tracking performance of a bagging machine. Each bag should contain a minimum of 50 pounds of sand. 10 bags are weighed at the start of each hour. This provides frequent data as well as a method of rationally subgrouping the data. The 10 bags are used to form a subgroup, so the subgroup size N is 10. The average weight of the 10 bag is calculated. This is the subgroup average. Standard deviation of the 10 bag is calculated. This is the subgroup standard deviation. So this is a X bar chart. The figure above is the X chart. The values are plotted on this chart. 3 lines are plotted on the chart. The middle line is the overall process average. The upper line is the upper control limit, and the lower line is the lower control limit. To build the X bar chart later, our team members Hidayah will explain how to build the X bar chart. So this is basic shape of S chart. Figure above is the chart, S chart. The subgroup standard deviation are plotted on this chart. 3 lines are plotted on this chart as well. The middle line is the average standard deviations. The other 2 lines are the upper and lower control limit for the subgroup standard deviation. So the bagging process represented by control charts above is in statistical control. Since the S chart is in statistical control, this means that the variation between the individual bag weights is consistent over time. We don't know what the next S value will be, but we do know that it will be between 0.06 and 0.34 with a long-term average of 0.2. Since the S chart is in statistical control, the variation is subgroup average is consistent over time. The next result will be between 50.1 and 50.49 with a long-term average of 50.3. The process is consistent and predictable in the near future.
Assalamualaikum to our doctor and to my group members. My name is Nur Hidayah binti Ishaq. Now I will continue the presentation for steps in construct X bar and S chart. There are 4 steps to construct X bar and S chart. For the first step is we need to gather the data. In this step, we have to select the subgroup size, which is N. Typical subgroup size for an X chart and S chart is more than 10. Select the frequency with which the data will be collected. For each subgroup, record the individual sample result. And for each subgroup also, we need to calculate the subgroup average, which is X, where X1 and X2, etc. are the individual sample result and N is the subgroup size. This is the formula for calculate the subgroup average, which is X bar equals to summation of X divided by N. After we calculate the average, we need to calculate the subgroup standard deviation for S chart, which is S equals to X minus X bar squared divided by N minus 1. The second step, we need to plot the data. In this step, we have to select the scale for the X and Y axis for both the X and S chart. Plot the subgroup standard deviation on the S chart and connect consecutive points with a straight line. And then we plot the subgroup average on the X chart and connect consecutive points with a straight line. For the third step, we need to calculate the average standard deviation S, where S1, S2, etc. are the standard deviation for subgroups 1, 2, etc. and K is the number of the subgroups. This is the formula for we calculate the average. S bar equals to summation of S divided by K. Plot S on the S chart as a solid line and label. For the X chart, we have to calculate the overall process average, where X1, X2, etc. are the subgroup average for subgroup 1, 2, etc. This is the formula, the overall process average we call as X double bar. This is the formula for we calculate the X double bar. X double bar equal to summation X bar divided by K. After we calculate the process average, we need to plot the overall process average on the X chart as a solid line and label. And then we have to calculate the control limit for the S chart. The upper control limit is given by UCLS. The lower control limit is given by LCLS. B4 and B3 are control chart constant that depend on the subgroup size. For your information, B4 and B3, we can get the values from the table that have been given. So this is the formula. This is the formula that we can calculate the UCLS and LCLS. For UCLS, the formula is B4 times S bar. For the LCLS, the formula is B3 times S bar. And then we plot the control limits on the chart as dashed line and label. For the X chart, we calculate the control limits for the X chart. The upper control limit is given by UCLX. The lower control limit is given by LCLX. A3 is control chart constant that depends on the subgroup size. It is same like S chart. The A3 value we can get in the table that have been given. This is the formula for UCLX and LCLX. For the UCLX, the formula is X double bar plus A3 times S bar. And LCLX, the formula is X double bar minus A3 times S bar. And then we plot the control limits on the X chart as dash line and label. For the last step, we need to interpret both charts for statistical control. After we calculate the control limits, we need to plot the chart. And after we plot the chart, we need to interpret both charts for statistical control. For this step, we always consider variation first. If the S chart is out of control, the control limits on the X chart are not valid since you do not have a good estimate of S. All tests for statistical control apply to the X chart. Points beyond the control limits, number of runs, and length for runs apply to the S chart. So that's all the steps in construct for the X chart and X bar chart. Next, I have continued the presentation with example of X bar and S chart. This is one example of construct the S bar and S chart. Let me read the question first. a packing organization monitoring the performance of a packing machine, each container should weigh 35 pounds during measure phase. Project team perform the process capability study and identify that the process is not capable. In analyze phase, collected 12 set of container weight with a subgroup size of 4. This is a table of the data. We have a 12 sample size and we have 4 subgroup. So, just now, we study about the step in construct the chart. Now, we have to practice it in this example. Same like the step, we need to measure the average of each subgroup, example X bar, then compute grade average of all X bar value. This will be center line of 4 X bar chart. Next, compute the standard deviation of each subgroup, then measure grade average of all standard values, example S bar, and this will be the center line for S chart. So this is the calculation that we have done for the data. This is the table for X bar minus X, and this is the table of X bar minus X squared, and this is the table of S bar. So this is the total that we have get. Next. Next, we need to determine the control limits. For this is the table that I have been mentioned just now, that we can get from this table is A2, A3, D3, D4, B3, and B4. The constant value that have in the formula for we calculate the control limits. The control chart constant are approximate values to measure the control limits for X bar, S chart, and other control chart based on subgroup size. This is the chart. After we get the constant value, we can put the value in the formula. So X bar chart, the formula is UCLX equals to X double bar. X double bar we can calculate from the formula, which is X double bar equals to summation of X divided by K. So for this data, we get 38.54 plus A3, 1.628 based on the chart just now, times S bar that we done calculate, which is 10.08, and we get the UCL is 54.96. Same like LCL, but different is we need to minus, and we get the LCS is 22.13. For S chart, the formula is UCL equals to B4 times S bar. Before we get the value from the chart given, so the before is 2.266 times 10.08, we get 22.85. For the LCL, we get a 0. After we calculate the control limits, we need to interpret X and bar chart. So we need to plot both X bar and S chart and identify the assignable causes. So first, we need to do a line for UCL and LCL. And then we need to do a line average. And then we plot for each data and we can get the pattern of the X bar and S chart. So from this case, we can get that from the both X bar and S chart, it is clearly evident that the most of the values are out of control, hence the process is not stable. That means out of control is some of the data is located outside the UCL or LCL. So if the data is located outside UCL and LCL, we call it as out of control. So that's all from me. Thank you.
So, for the application of X bar and S, first we need to know when to use X bar and S chart. X bar and S chart are used to analyze a process operating over time. Like all control charts, they will send a signal when a special cause of variation is present. You can use X bar and S charts for any subgroup size greater than 1. This means they can be used in place of X bar and S charts all the time. But you definitely should use the X bar and S chart when the subgroup size is 10 or more. The standard deviation gives a better estimate of the variation in large subgroup than the range does. So this is example of a backend organization monitoring the performance of vending machine. In analyze phase, collected 12 sets of container weights with a subgroup size. To demonstrate an example, we just took subgroup size 4 in the example, but it is always recommended to the 10 and above for and SJ.
Okay, hi. I will talk about benefits of using XBAR and SChart. So, the first benefits will be the XBAR and XChart often used to examine the process and standard deviation over the time. These charts are used when the subgroups have large sample size, and S-chart provide better understanding of the spread of subgroup data than range. The second benefit is standard deviation takes into account all the data. Advantage of using standard deviation instead of the range is that the standard deviation takes into all account, not just the maximum and the minimum. The last benefits will be use X as chart when the subgroup size is 10 or more. The standard deviation gives a better estimate of the variation in large subgroups than the range does. That's all from me.